Hello, everyone, and welcome to this new Conself webinar. My name is Alessandro, and today I'm going to show you how to perform a CFD analysis in a building context. So first, a few words about Conself. As you can see on this slide, we are an Italian-based company with different operative locations around Italy, but also a lot of distributors are all around the world. This is the third webinar of this session, and you can find our references from website, LinkedIn page, and mail address on this slide. And just a few more words about what we do. As you can see here, we have three businesses. The most important one is a simulation platform on the cloud. That is what I'm going to show you today. On this platform, accessible through a common web browser, you can perform fluid dynamics and stress analysis simulation. We also have a cloud computing service that basically is a cloud infrastructure on demand for all those customers that need high-performance hardware in short times, and they don't want to afford a big investment, and so they can rely on our pay-per-use computing power. Finally, we also have an engineering consulting service to optimize design and to introduce simulation technology into the design process. So let's focus on what we are going to see today. And here in this slide, you can see the simulation domain. That is basically a few simplified buildings describing a piece of a city inside a bounding box. That is our computational domain. We are going to let the air flows in from the inlet and flow out from the outlet. Then we have ground, where the buildings are placed, and lateral walls. So this webinar will show you how to set up a CFD simulation in this context. We will then take a look at pressure and velocity contours at the end of the simulation, as well as a method to evaluate pressure loads on surfaces that can be of interest for all those of you who need to evaluate pressure loads on buildings to evaluate the structure resistance. So let's start with the simulation, and in order to do so, I have to switch from the presentation to the browser. So as you're going to see, I'm using Google Chrome, but you can see all major browsers such as Mozilla, Safari, Internet Explorer, and in every operative system you have. So everything starts from our main page, our website, conself.com. Here you have on the top menu with a different choice of argument. Here you have, for example, a services where you can take a look at the simulation on the cloud description in the dedicated page. So there are a few information about how it works, demo, price lists, and so on. Another important page is the blog page. Under community menu, you have the blog and the webinars that are both interesting pages. In the blog, you can find a lot of technical articles dealing with both general questions, with general aspects of fluid dynamics and stress analysis, but also on particular features of our platform. And in the webinar and tutorials, you will find all our webinars held so far. So this one is going to appear here too, as well as all others we already have. So now our platform has a welcome plan. So basically, every user can sign up for it. It's called the welcome plan, and it will give you 20 simulation credits per month for free, forever. In order to obtain the welcome plan, you have to go to the store, products, cloud simulation plans, and here is the welcome plan. You have just to insert your name and choose a password, and then you are good to go. Okay, in order to sign up to the simulation platform, you have to go to the login page here, and insert your credential. And in my case, I have my account already here. And clicking login, you will be redirected inside the platform. Okay, so as you can see, there is a left side menu here with different tabs. The first one is the dashboard that presents some information about your account, like credits, both spent and remaining, all the steps you already run, credits spent per each case. There is another tab, the storage one, that also has different information, but regarding, in this case, the storage occupied by your cases. Here you have a full list of cases. You can delete them. You can see how many steps you run on that case and the amount of storage and so on. And finally, we have the simulations tab. Here you can create a new case, select and open an old one, and monitor those which are in progress. So now today we are going to see a simulation in a building environment. So the first thing to do to create a new case is to select the application we want to use. In our case, the general one is okay. So let's call it City Webinar, and let's click Create. Here you will start right here our process. Okay, we start from geometry, and then we will go through meshing, simulation, that can be CFD or stress analysis, and then results. Everything will be performed in a common browser from start to finish. So the first thing to do is to upload or import, in general, a CAD file. You can directly import it from Onshape, that is a full cloud CAD. We are integrated with it, and as you can see, clicking here will let you import a geometry directly from Onshape. In my case, I have my geometry on my PC, so I click just file upload, and I select city step file. Clicking open, the upload will start, and once it has been completed, you will see on the right side a graphical window showing our geometry. And so here it is. As you can see, we have a few very simple buildings, and let's say we want to simulate a wind directed in the opposite direction with respect to the x-axis, so flowing from x plus to x minus. And okay, so we have to start few geometry elaboration. The first one, we have to choose the file units. In case you don't remember in which unit you create your case, you have to check your sizes by clicking on the eye here. So now As you can see, X, Y, and Z are around 500,000. So it appears to be in millimeters. And so the default selection here can be okay. We click next and we go to the second section where we have to define the domain. You have to choose between internal or external. So in this case, it's clearly an external flow. And once you select that, you are asked to insert 6 different values to define your bounding box. That is basically the box inside which you are going to put your geometry, okay, your domain, your computational domain. It is defined by means of deltas, meaning that each one of these numbers prescribe the distance between that boundary, let's say that side of your bounding box, let's say it's minus, from the lowest x coordinate of your geometry. It's very clear for the z-axis, that is the vertical direction. And if we want that our buildings lay on ground, we have to place 0 here. Okay. So remember, you have to prescribe these deltas in terms of file units. For all other sides, we can use, let's say, 100 meters for X and for Y. And this can be good enough for, in our case, for this geometry. And so we are good with the bounding box. Now we have to group, for example, our buildings. We can group them all together. They are going to act as all at the same, in the same way, and they will act as walls opposing to the flow. But in case we want to highlight a particular building, we can select all the boundaries composing that building. Here you can see what I'm doing. And once you do that, you can create a single boundary for it. We're clicking Create Boundary, Building A, and then we can group all remaining buildings together by selecting all them. And clicking again, Create Buildings. Okay, now that we grouped all the surfaces in our geometry, we are good to go, and we can submit and conclude the geometry step. Once you do that, you will see a new case appearing here in the Case in Progress tab. This is a very quick step, the geometry one. It just has to group together surfaces. So we will have to wait just a few seconds after the system takes this job and runs it. And once it will be complete, we will see this new case appearing here on our selection of case menu, and we will be able to open it and to see the new our buildings inside the new domain. And all other steps from Mesh 2D, Mesh 3D, and CFD will be will need a few minutes in order to complete the calculation. So I already have a case that I will show you, and this way we can go through all the steps quite quickly, and in order to avoid to wait for the system to complete the simulation. So let's just wait a few more seconds and see this case should be gone very quickly if our queue is small enough. Okay, so here you see City Webinar. We can open it, and we are in Mesh 2D. We moved from geometry to Mesh 2D. So our step-by-step process is proceeding. The first thing to do in all these steps, the following steps, is to choose from where we want to start. We want to start from geometry step we just run. We open it, and you see we have our bounding box with our buildings. Okay, so these buildings lay on ground, and we have them divided with building A and buildings. So now we are ready to start our meshing procedure. First thing to do is the mesh 2D, that is basically a surface mesh. We are going to prescribe 2 parameters per each boundary, and in order to define our surface mesh. So on the boundary selection menu, you have a lot of different boundaries. All those we defined already, and we have building A and buildings plus 6 boundaries that are all 6 sizes of our bounding box. For each of them, you have to prescribe two setups, two settings. And the first one is the uniformity level. This basically rules the speed at which our mesh will change the dimension of triangles from big to small in case we have two zones that are near each other with different mesh sizes. The mesh sizes will rule, it's a characteristic dimension that will rule the dimension of triangles that will cover that region. So let's say the ground will have small triangles and the side will have big triangles. The velocity at which these triangles will change from small to big is ruled by uniformity level. As higher the uniformity, the slower, the smoother will be our surface mesh. So from now on, we will always have international system unit of measure. So as you will see here, we have 704 meters, around 600 meters, and 145 meters on Z. So we can prescribe like 2 meters for the buildings and 4 meters for Z minus, that is the ground, and 8 meters for all other boundaries. We have to prescribe to all of them. And so at the end of the process, we can click submit and our surface mesh will be ready. As I said before, I already have my case ready, and so I'm going to open it. And as you can see here, we are in the last step because I already run all of these steps. We just finished Mesh 2D, so let's go to Mesh 3D and see the results of our Mesh 2D process. As you can see, you have different Mesh 2D from which you can select where to start from. We select one of them, and the graphical window will show us how our mesh will look like. And so here, as you can see, our bounding box is divided in many triangles and with different refinement depending on what we choose in our mesh 2D section. So that's our surface mesh. And now we have to fill the volume of our domain with volume mesh. You can choose between 2 different algorithms, and we are going to use the hexaedral one. We prescribed 8 meters for the boundaries on sides, so we can choose a maximum element size in our domain of 16 meters. Then we can click next, and here we have the boundary treatment. In order to find additional information about the settings, you can go into the user manual and take a look. Here you have a step-by-step procedure showing you the meaning of each parameter you encounter. So here you see, in case of the hexaedral, we have 2 different parameters to set the layers number and the first cell dimension. So basically, their meaning is shown in this picture. The dimension will rule the size of the cell near the surface, and the layers will rule the number of layers we impose of the same cell dimension. In this case, we can use 3 layers, and let's say 1 meter is on the building A, and that can be okay for us. And we can click Submit, and the Mesh 3D will start. So let's take a look at the results of this phase. So we can start from our Mesh 3D step, opening it here. As you will see, this graphical window will appear slightly different. This is because we have here a more powerful graphical window that will allow us to create clips and look inside our domain to discover if our mesh is good enough or not. Highlighting the system.form file, you can take a look at the information to discover the number of cells of our domain. As you can see here, it's a very coarse mesh with under 300,000 cells. It's just, to show you how to perform a complete simulation on our simulation platform. But of course, if you want accurate results, you have to prescribe a higher number of cells. In order to find out how the mesh looks like inside the domain, we can cut it with a clip and ask to show it with edges by clicking OK. You can see here under very near to our buildings we have a refinement, and so that's how our mesh looks like. Now let's start focusing on how to set up the CFD part. There are 3 sections. The first one deals with fluid models. We have to choose a fluid model between compressible or incompressible. In our case, even if we are dealing with air, it can be treated as an incompressible fluid due to small velocity involved. Then you have to choose the turbulence models. Volatile mass can be good enough in this case. You have to assign the fluid properties, density here, and viscosity here. And then you have to initialize your fluid and your turbulence. We are using 1 atmosphere, 0 velocity, and the turbulence initialization can be prescribed equal to the fluid viscosity. So let's move to the boundary condition section. Here, for each boundary, you have to prescribe the behavior of that boundary. So for buildings, we have the default one that is good enough. The wall no slip can be a good choice for our buildings, so building A, the buildings, and also for the ground, so Z minus. For lateral walls that are Y minus and Y max, we can prescribe the symmetry condition. Our wind is aligned with the X direction, so the symmetry can be prescribed on Y and also on Z max. Finally, X minus, we were saying that the wind will be flowing in the opposite direction with respect to X. So the X minus will be the outlet, and we can impose the pressure on it, and the X plus is the inlet, and we can prescribe a velocity that will be perpendicular to that boundary, let's say 10 meters per second. Okay, we are good to go with the boundaries. We can move to the simulation settings. We can choose between steady and transient. In our case, let's choose steady, 2000 iterations, and 500 the frequency. We want to save the solution. Okay, clicking submit, we will be able to run the CFD, and at the end of the process, we have the possibility to take a look at the results. So moving to the last step, results, we can load our solution and we can perform the post-processing directly online with our browser. And as you can see, again, we have our geometry shown here. First thing to do is to select the small block and move to the last iteration. And then we can highlight the file, make the range of the values for our pressure a little bit smoother. Then we can apply a slice. Let's say we want to take a look inside the domain with a slice, a slice that is oriented as with the normal in Z, place it 10 meters over the ground. We can click apply, and you see here the wind is flowing from our right, so the pressure, the peak is placed in front of the building facing the wind. And we can also take a look at the velocity, and as you can see, we have a flow that encounter our buildings, then we have the wake behind our buildings. So let's take a look at the pressure over our buildings instead of the field around them. So we can zoom inside our bounding box, and you will see we have obviously those buildings that are facing the wind directly, they will have a peak load. And let's say we were interested about our building A, and as you can see from this point of view, it's somehow shaded from the main building in front of it. So the pressure can be considered lower with respect to the one, this one, the big building is facing. All this data in terms of pressure distributed on all these buildings can be used to as inputs to structural analysis in order to find out loads on these buildings. In order to do so, with the download results button here, you will receive the solution file, but also a particular file that will allow you to use this data as inputs for your stress analysis on your buildings. And I'm going to show you how these data are arranged in our file. It's a very simple file, so I'm going to open it. It's inside the result folder, sampling surfaces. You choose the iteration you want to obtain results, and you will see a p-walls interpolated .raw, and that's our file that will show you a very simple way to perform your load evaluation. So here you can see this is the file, and as you can see, you have 3 coordinates, x, y, and z, that identify the point and a value of pressure. So this way, you are able to apply a pressure and interpolate it on your load file that you will have to input to your stress analysis software. This way, you can take into account the output of CFD simulation to associate this analysis with the common stress analysis on your buildings. So let's shift now from here to the last slide. And here you can see how you're able to ask questions if you want. And I will answer them live here. In the meantime, I just wanted to highlight few features about our software. We are based on OpenFOAM and Codaster, two major softwares that are validated and certified in order to assure you the best accuracy and quality of your results. Remember, you have a free plan to evaluate the platform. You can sign up for the welcome plan from our website, concept.com. There's no need of payment data like credit card or something like that. It's always free. Every month you have 20 simulation credits to try the platform, and you are able to try your geometries, perform meshes and CFD analysis or stress analysis. And once you will be comfortable with that, you can choose between a lot of different paid plans. They differ in terms of amount of simulation you can do, duration of the subscription, because you can have a 1 month subscription or a 1 year one. So a lot of different choices. And remember, we also are available for a dedicated development in case of specific application are needed, or in case features that are not online are needed to your specific requirements. So let's write us an email and we can discuss about common development you can need. So that's all. Thank you all for watching, and stay tuned with us, mainly with our website or our LinkedIn page, and follow our next events in the near future. Bye-bye.